Well, hi, good morning, and thank you so much for joining me in my shop here. Today is July 30th. Another beautiful day going to be here. Now, I got a few things to say about this radio. After all the testing and fooling around and all the stuff I've done, my conclusion right at this point is there's actually two problems going on in this radio. One of them is somewhat manufactured by me, and that's the problem with the slug inside the original IF transformer. That's one problem, and the reason it's a problem is I don't think I've resolved it with the newly installed alternate IF transformer. I think that thing is still a problem in itself. The other problem, I believe, is weak oscillator tube. So the oscillator tube is a 1L6. That would be this guy up here. Known to have a shorter life than most. It's an oscillator tube. It has a oscillators kind of run hard, so it's another hard running tube. It tends to wear out a little earlier than other tubes. This radio exhibits extremely weak output. If I pump a strong enough signal into the radio, it will come out the speaker. So where is the weakness coming from? So the two possibilities are the weak 1L6 oscillator tube, and the other one is, of course, the IF can is just so badly mistuned. I think the main problem here is the weak 1L6, I think. Now, I tested the tube. I may have tested it in a tube tester that does what's called a whole tube test. There's actually two amplifiers inside this tube, and they can be tested independently. There's two separate grids that can be tested independently. But a lot of tube testers in this situation will just test the whole thing at once. And I may have done that, I can't remember. So this time we're going to find a tube tester that'll test both parts of this tube separately. And we can see then if the local oscillator part is weak. And I would have to guess if, you know, they share a heater, they share a plate. The heater's acting as a cathode. I would think if it's weak, if it's weak as an oscillator, it's weak as an amplifier too. It's two grids in one tube. It's not two separate tubes. Okay, I'm going to get set up to do that and make sure I've got a tester that'll do two tests. Okay, let's take a look at this tube tester. So this is a Weston 981. Is that 981? 981. Type 3 is a good tube tester. But if you're going to test a 1L6, there's only going to be one test. The whole tube will be tested at once. That's what this one will do. My 966 here, which we're going to put here. So this guy, if you dial up 1L6. Oh my gosh, how did we... Excuse me a second. Yeah, you go out, okay? I'll show you what just happened. So you see the back of my door, it's got all those wires. When I heard the sound and looked, my cat was hanging among those wires. Briefly. He didn't last long up there. Okay. So this tube tester, when you dial up 1L6, you get two listings. One of them is called the pentode section, and the other one is called the... Oh, okay, so this is the oscillator side, and it has a note here, micromodes only, OK over 200 oscillator section. OK over 200. Huh, and then it has a number 300 here as the target value. 825 up here. Okay, well, it's got the two tests on it, and you can already see. It's a little tricky to test an oscillator. It's quite tricky to test an oscillator in a radio. If the oscillator is operating, it generates its own bias. And thank you for reminding me of this. Fellow who sent me an email, whose name will remain anonymous, just pointing out, and I did realize this too, that in most oscillator circuits, when these oscillators oscillate, they produce their own bias. And so one of the ways to tell if the oscillator is operating is you look for that bias. The problem is when you go to measure the bias, You disturb it, the oscillator stops, and you don't see the bias. Take your meter away, it's there. Put your meter on, it's gone. And this is kind of the challenge with this particular part of a radio like this. Knowing the oscillator is operating is tricky, but I use an SDR to find that out. Remember when we tried that, I had trouble spotting the local oscillator, although in some cases it did seem to be there. And if I've got it right, oscillators have a harder time at the lower frequency end than the higher frequency end, which might sound a little backwards, but so be it. Okay, let's plug in this guy. We'll do the two tests and see what we get. Yikes, a lot of balance here. Better, okay. 1L6, 1.5 volts for the heater. DX for the heater connections. DX. 62518. 6251 with an 8 at the end. 18 on the bias. 39 on the English. But it says micromos only. I think what it's saying is don't use the English replacing good thing. We're going to set this to 300 because we're only going to read, it's just a little tiny upswing here, almost nothing. Well, actually, for this part of the tube, the upswing is higher, 825. So we got to be above my finger here, and it's good. Okay, double checking. 1.5 DX 6251, 6251, 8, 18, 39, 520, and you throw it away. So if we can't get above 520, we throw it away. Good tube, 825. Okay, we'll do the short test. You're watching this light now to see if there's a short in the, I haven't put the tube in. That's not going to go well without the tube in there. Okay, these tubes are ready to go almost immediately, so we're looking now for shorts. Flash is okay. If it stays on, we're in trouble. It did not stay on. P4 520, above my finger. Way above my finger. Way, way, way above. Okay, now we're going to do the next test, which is the oscillator side of this tube. We're bearing in mind, well, never, don't bear anything in mind. DX 8152. 8152 with a 6. 40. 73. Press P4. Micromos only, okay over 200. Yet they write 300 there. So, 200 is just right here. It's just barely up on the meter. We can hardly see the meter in the camera. Okay. Short test again, although I don't know if you really need to do it. And it's P4, 300. Well, it's well above 300. Well, no, it's not well above. It's at 300. It's right at 300. It says oscillator operates over 200. And it gives a 300 as the target, not the replace level. There's no replace number. It's just this is what it should be, and it's exactly what it's measuring. Well, I'm a little disappointed in a way because that means this tube is not the problem. Well, that means I don't know what the problem is. Although, really, it just boils back down to that transformer. That transformer has really been the story of this radio. Okay, so I'm going to take out the plug extender. We're going to go on the assumption now that the local oscillator is working properly. Well, maybe it's not, just because the tube measured good doesn't mean the circuit's good. But for now, that's really how I have to go. So now we're back to the IF transformer. So the IF transformer is a tank circuit on the primary. And at resonance, the tank circuit presents a high impedance. Off resonance, it presents a low impedance. So if you had, how can I think of this now? The best way for me to think of this is to go drink a little bit of coffee right now. But what I was going to say is that while the 455 frequency or oscillation is not depleted by the tank circuit, everything else is depleted. So it's possible on the plate of the oscillator tube you cannot find anything but 455 or the tuned frequency of the IF, which in my case may be 430 or something like that. That's the only thing you would see there. Everything else gone. You know what? We've got to do something here. We've got to do something right. Got to do something right. Got to do something right. Coffee. So what I'm going to try to do here is hook up the oscilloscope. I'm not going to try this. I'm going to do this. I'm hooking up the oscilloscope right at this location here, ahead of the big resistor here, and before this capacitor. So right here will be the DC output voltage coming from here, and the signal also will be here. The audio signal will be here. I'm going to put that on the scope. Meanwhile, I'm going to feed in right into the loop antenna a sweep signal from the sweep generator. That should run through the whole radio, IF and everything. We should take a look at the output as we see it on the scope and read it and weep at that point. Okay, in case you're wondering what the roar is, that's my air conditioner coming on. So the sweep generator is sweeping right through the broadcast band from the low end to the top. The radio, I'm pretty sure, is on the broadcast band. Pretty sure about that. Oh, I can see it right here now. Got the radio tipped up. Yes, definitely. Broadcast band. Antenna loop is sitting here. And you can see the oscilloscope. It needs to warm up for just a few minutes here. Okay, I think we're ready to go here. Sweeper is sweeping, scope is scoping. Radio's not radioing yet. Okay, let's make the radio radio. Here we go. The radio's on, I can hear it. Now you can hear it too. Well, that should be... Probably I don't have the sweep turned up high enough. There we are. Okay, so I'm going to turn down the volume. Because I've hooked the scope up to basically where the AVC voltage is available, I don't need to have the volume up. So we can crank this up a little more. Lovely. You see something right there. When I tune the radio, that should move. Thank you. Thank you very much. Now. Oh, okay. What was what? Am I just tuning in one direction the whole time? Let's just keep going. Hey, where's the buzzy sound? That's a volume turned very, very high. So at this end of the band, it doesn't hear that sound. I didn't notice that before. That interference comes along with tuning the radio here. Oh wow, explain all that. That's a little more than I was expecting. Those crashing sounds are my cats playing with some paper bags and boxes. Well, that's a little more than what I bargained for. How can we we understand any of this stuff? So first of all, what am I sending into the radio? So I'm sending a beacon, basically, a single frequency, which is moving through the band and then starting over again. Through the band, starting over. Through the band, starting over. So starting around 500. Listen to those cats. Starting around 400. You know what? I'm sweeping through the IF is what I'm doing here. I'm not doing what I said I'm doing. I'm full of crap. This guy's full of crap, man. Yeah, I'm starting at 400. That's no good. We don't want to start there. We want to start. We want this starting at 500. Okay, so that's 500. That's the bottom of the AM band, and we want it stopping way up at 1500. And probably so we're on the one. Okay, we got to do this whole thing again. Let's go back to the start frequency. Hear the radio reacting to this. So we're starting at 500, just below, and we're going to go up to 1500. Money, eh? So this right now is generating a fixed frequency that you can read. So this is sending out a 16 kilohertz, 1600 kilohertz signal, and we really shouldn't hear it. Stuff. We won't try to analyze any of it. We'll put this at 1600. That's the top of the band, and we'll set it sweeping by doing that. We'll turn this down. Turn this down. I'm blowing the heck out of things here. Put the camera down. Now what do we got? Piles of gibberish out here. Let me tone this down a little lower, because I'm pretty sure I'm just maybe overdriving this hugely. It's funny, you know, I'm using a loop antenna to fire the signal into the radio. You gotta kind of wonder just how easy it is to overpower the radio. But here we've got one nice clean signal at one end. That would be at the high end, and the radio right now is tuned to the high end, so I'm pretty sure this is correct. And what's happening is if I crank this up, we get all kinds of weirdness. Just wonder what was happening. So keep this down like that. I'll tune the radio. Oh, just went away. What's this other one growing on? What's this? These are all things I just would not expect to see, but there they are. Let's keep tuning, because you never know what's down at the end. So now that looks like, oh, ooh, what's happening there? It's a very powerful signal there that it's picking up. Is it the lower end of the sweep? Let me stop the sweep here. Okay, well, it's definitely related to the sweep generator. Could this be the stop frequency? What I can do is I can just move the stop frequency up a touch. No, it's not the stop frequency. The thing's moving around on the screen because I'm changing the range of the sweep. Well, okay, I got something interesting on the screen. I don't know. I don't know what to think of it now. You know, so what? This is the so what moment. Make this a little less sensitive. That's another thing. I may have had the scope so sensitive that I'm running the signals too low, but so sensitive it's picking up nonsense. Does that make any sense? Here we are. Let's tune the radio. It's definitely something happening right there. What happened to the sweep? Did I turn? What happened to the sweep? It's not supposed to go away. It should still be there. Are we not? We're not sweeping? We're sweeping. That's me changing the sweep input level. How to interpret this? Am I finding that there's very little output on the IF? Is that what we're finding here? And how surprising would that be? I've got a replaced IF transformer that's almost certainly tuned way off. So what would we want to do with this? Well, yeah, that's a good question. What are you trying to do here, Jim? To some degree, I'm poking around because I don't really know exactly what to do or how to nail down this problem that the hum and the weakness. The hum and the weakness. And I kind of lost touch with what I'm trying to achieve here. Trying to sweep through both IFs. We should get one nice response curve and nothing more. And that response curve should move around as I tune the radio with a sweep signal crossing the entire band. Well, what we're getting instead is at certain spots they get a big response, a tuning response there. And there was another one, wasn't there? Or it just gets bigger as we go up. Ooh. Its cousin showed up here. And we just got off the end of the sweep. The sweep's not quite high enough. Let me check the upper frequency here. 1601. So I'm going to raise it to, say, 1750 or something like that. So now we got a little more piece here to look at. And we've gone off again. Oh, that's interesting. How come we're going off at 1700? Because the AM band ends at 17 or 16, depending upon how you look at it. When you look at it. So the radio appears to be tuning beyond the end of the band by a long shot. What does it show on the scale? So it shows it's stopping at 16. Although you could run the pointer all the way to here, which would be 17. I think you can get the pointer all the way there. But it's tuning well beyond 17. So what's that suggest? Incorrect IF frequency. Other alignment issues. Oscillators off frequency. When I check the oscillator with the SDR, which I admit is a very loosey-goosey way of doing it, the impression I got at the end of that was the oscillator was weak. But the tube is strong. Oh my gosh. Come on, we gotta get something out of this. You know what? I got the right setup here to discover something, and I just can't get my head around what it is I'm trying to discover. I'm trying to discover if this works. That's really what we're aiming for. The new transformer. Tuned at random right now. Well, what if I try detecting the signal coming out of the first IF? This is the first IF, John. That's too bad. I already blew it there. It is the first IF that has this problem. Go back to feeding 455 into it, into the radio. Now, let me try that again. Coffee break time. Okay, let's change the sweep generator here to cover the IF. So I'll start it at just below the IF. We can flip this back here like this. Make it a little easier. We want to start this at say 455 is the middle. So if we go down 25 from 455, no, you know what? I better make this even wider. I'm not going to worry about centering it. I'm just going to start it at 400. There's 400, and we're going to stop it at 500. Okay, that's 500. And let her rip. Nothing. So the sweep generator, my frequency counter will show me the average, roughly the average, or the middle of the sweep, 449. We're not hearing anything at all? That would mean the IF is out. The IF tuning is outside the range of my sweep right now. Well, we'll just widen it out even bigger. Started lower, take it higher and higher. Now we're starting at 100 kilocycles and we're stopping at 600. Let's go even higher, 600, 750. That's what we're sweeping now. That's what's on here. So the IF is, I don't know, yeah, right, yeah. I'm not making sentences anymore. We should be hearing this. I am jamming it through the antenna, which maybe is weak. Let me boost up the... Wow, that made a big difference. 20 decibels. Now we hear it. And now we can see it. Okay, let me turn this down, because we really don't want to hear it. We do want to see it. What's going on down the hall here? Oh, that was the end of a cat fight. No, they're not going to do it again, eh? I guess the winner walks away or something like that. Okay. That knows enough to throw me off. Right, so we would wonder, what frequency is this? You know, I can close the sweep down onto it and get an idea of where this is actually. I'm going to tune the radio. Let's do a few things first. A little more, and we see something else is showing up here, but let's just concentrate on this one. So, again, sweep is starting at 118. Oh my gosh, really? And it's stopping at 750. And in the middle, it's 400. So it's about 430 here. This is way, way, way low, this frequency. So what I'm going to do is I'm going to reduce the upper range of the scan. I'm going to bring it down, down, down. As I do that, this thing will get bigger and move to the right. That should be what happens. That's as low as I can get here. Yeah, basically. And then I'm going to do the other one by raising it. What are you trying to do? I'm trying to close this thing down on the sweep. So as I do this, the sweep should get bigger and bigger also. So getting bigger. Whoops. Okay. Can we make it bigger yet? Okay, where are we at here? So So now the starting of the sweep is at 188 still. So this is 188 kilocycles here, and the stop frequency is 247 out here. Everything is here. That's like 200 instead of 455. What is going on? Let me start the sweep again here. I tuned the radio. Does it do anything? It should not. Okay, so you can see there's some tuned signal coming in also. That's a little weird. And the band change should have no effect, so I'm going to do it. Let's see what happens. There's my little tool here. What did I just do? We're going up. This, the indicator here didn't move. How come it didn't move? Because of this cord? Because of why? There we go. Yeah, I can see where we are. This is broadcast band now? I don't think so. I don't think so. I think this is the broadcast band. Well, I wasn't watching the scope, and the thing has disappeared. Where did it go? Just have to be a little more careful here because we've got this ground wire coming right up next to the capacitor positives. A little bit of movement there. Bowie. Don't want that. Okay, I've sort of lost complete control here. I'm now in a different band setting because I think I'm in the wrong band setting. Holy smokes! Somebody help me sort myself out here. This isn't going to help because I don't really know where to put. Yes, I do know where to put this plate. This plate has screws on it. Yes, I do know. It's going to sit right on the bottom, just like that. So we are on long wave. Long wave. Oh, I've lost complete control here. Somehow I convinced myself that this is the broadcast band. But you know what? I think it's a long wave band. No. No, you know what? I don't know what the heck I'm doing. That's what this boils down to. Jim, you don't know what's going on. You haven't got a clue. That would be broadcast. That would be broadcast like that. There's our IF frequency. Boy, oh boy, it's just 50,000 miles out. Is it really there? If I tune the IF transformers, does that thing move around? He says, wistfully, okay, picking the second IF, random, right in the slot, amazing. Watch the screen now. Oh, popped out. How do you like that? How do you like that? How do you like that? So, is that really telling me something? It's telling me I tuned the transformer further away from this frequency. It didn't tell me the transformer's tuned to that frequency or anything like that at all. So I really don't want to try to make this bigger. This is way off. Well, I'm trying to make something at 455 double this frequency. Bigger. There's nothing there. So I'm going to try to move this. I want to move this. I want to move the resonant point. I want to make it bigger. I want to move it. Seems to me, from my experience, and I really haven't looked at this in any kind of sort of scientific way, but it looks like when you tune the primary, you vary the frequency, and when you tune the secondary, you vary the amplitude. I don't think that's necessarily the case, but it seems to be the case. So we're gonna try that, and I don't know which one's the primary and secondary offhand, but it seems like I've tuned the bottom one and we got an amplitude variation. Let me try the top in the same one and see if we can move it. No, it's really hanging on to that spot there, isn't it? Now is that because that's what's being sent by this guy? This guy I put in is tuned at 200. The sweep is going by and sending it 200 forward. So it's really this guy that's way out, and it's giving me trouble tuning. So I'm going to start on the bottom here because it's right there. And I'm going to put my finger on top of this and hold it. Okay, watching now. Why does it love this spot so much? Okay, so I'm doing the bottom one. Let's do the top one now. Okay, it's a little tricky because I'm not holding on to the can here. Okay, I'm moving the slug. I'm moving the slug. That's, you know, it's behaving as if this is 455 kilohertz and you're just moving the slugs around to tune it up a little bit. That's what it seems to be behaving like. Am I just totally wrong about this? I can't be. I can't be totally wrong about the frequency there. Is some kind of weird harmonic thing happening? I don't see it. We're feeding it a pretty heavy signal, but I am using the loop to push the signal into the antenna. So we don't really know how much signal is getting into the radio. Normally this would be really powerful. Yeah, right. Miles and miles off. Is this like a sub-resonance? Or, you know, does that even make sense? There's no such thing. I'm making stuff up now. We need to look at 455 back on here again because maybe this is maybe there's another peak up at 455. Especially if we can hear. Why would there be another peak at 455? Only if those transformers are tuned to 455. I don't think they are, but they're tuned to 430, I thought. Way above this. Okay, so I'm going to extend the sweep upwards. This will cause this thing to shrink and move this way. Here we go. Okay, so now the sweep is centered on roughly 455. So roughly this is 455 in here. I see a little tiny bip up here. There's something happening right on the edge here. Let's go a little higher. So this is probably what the radio's tuned to. It's probably high enough now it's getting in. Oh no, the radio's tuned up at the top frequency. Well, I'm going to tune the radio a bit. We'll see what happens. So probably a harmonic or something is getting all the way up to where the radio is actually tuned. So this would be the tuned frequency going into the radio up maybe 600. Oh no, way up high. So we're tuned up here around 1200, something like that. So this is probably double 600 happening here. Don't know what that is. A little bit of nonsense there. And then this is the 200. 200. Really, let me change the sweep again to bring that back towards the middle. Is it really 200? How can it be anything else? How can I be fooled by this setup somehow? And that's really 450. Radius 200. What the heck is it doing down there? It's just really no question that it's 200 or so. Jeepers creepers. You know, like another obvious thing is this transformer that I installed just will not work for reasons who knows what. I have no idea why it wouldn't work. It is a 455 coil. 455 kilohertz written right on it. Looking on the scope at the signal before it gets into the rest of the radio. So it's just the output of the IF, just after the detector. So now I know where it is. It's around 200 kilohertz. I can look for it properly, because before I was restricting my search to 400 to 500. That's way off at 200. So maybe I should try to inject the sweep. Try to see the output of the first transformer. How sensitive is the first transformer to touching stuff to it? So let me grab a big fat screwdriver here. This isn't so big and fat. Just touch stuff and watch how the scope is affected. The reason I'm doing this, I think that's that short. Well, why did that happen exactly? Yeah, I think I managed to develop a short by pushing on it, pushing it into the chassis. Okay, looks like I can just move the scope to the output side of this transformer and without disturbing things. You know what I can do? No, I can't do this. I can't. I have two scopes. I can do this. But I haven't used my other scope for quite a while, the one that's up on top there. And the idea is I want to be able to see the signal that we're looking at right now. Yeah, let's just leave this just like this, and we'll try the other scope. Is it even plugged in? I haven't had this on for goodness knows how long. Yeah, it's plugged in. This particular scope I picked up off the front lawn of somebody's house. They put it out at the end of their driveway. Take it if you want it. Well, I took it. Like I say, it hasn't been on for a long time. Okay, so I need a lead, test lead from there. And the sweep. What are we doing with the sweep? In this case, we're still going to want to use the sweep coming out of the sweep generator. Let's just see if this is going to work at all. So does this have has a XY setting? So I think that's where I need to be. There's there it is sweeping. Speed it up a little bit. Looks good to me. And center it. Or center it vertically. Where are you? Y1, Y2. There we go. No, that's left and right. Oh, I got the other one on, that's why. Okay, I see what's going on. I'm set here. So now I can take this scope and we can look at what's going on with this transformer. And I want to ground this the same way as the other one. Yikes, I don't want to stick another clip lead up there. Getting a little hairy. Another good spot would be the capacitor that goes to the chassis. Where did that guy go? The capacitor that goes to the chassis. That's this green one here. You can see the connection there. The other side of it is a B minus. And this whole area here is a B minus. Three terminals here. Okay, now we're going to attach the scope on the times 10 scale. This guy's set to 0.2 right now. Which one was the output? Don't remember. Let's just put it here and see what we get. What do we get? I don't see anything there at all. I'm going to go times 1. Don't see a thing. Okay, so that maybe that's the wrong one. Now, so we go on the other terminal. That's this red one here. Let me just touch it briefly. Oh, wait a minute, times 10. Well, we're sucking away a bit of signal. Let's put it on there. Make this more sensitive yet. Oh, I went the wrong way. I made it less sensitive. There we are. Now we got something interesting. Now, how can I get that on the camera? I can just tip this one up. That is kind of kind of lousy to look at. What I'm going to do is I'm going to bring this camera over. I'm going to kind of watch two scopes at a time anyway here. So this is triggering on what? What is it triggering on? It's triggering on Y1. There we go. Now you're seeing something pretty weird. You're seeing this thing go across like that. I don't see that. That's a shutter effect. If I change the speed here, maybe that'll change the speed of that shutter effect. No, you're just gonna have to live with it. So I got a thing here and a thing here. These are weird looking things. They look like a bow tie. Looks like two resonant circuits at two different frequencies. This is similar to what I saw before when I tried something like this. There seem to be two. Well, there could be two. It's a transformer with a primary and a secondary. They're both tuned and they both have their own slugs. Can we tell what frequency that is? No, because I'm not using an XY sweep here at all. This is a time sweep. I need to change this to an XY sweep. Can I do it from the front? X, Y. Looks like you just switch it to XY and then this becomes the sweep input. Let's put it on XY, see if it stops. Yes, it does. So I'm going to have to feed the signal that's here into here. I can do a shared thing. Let's see what I can do here. Okay. Oh no, not now. This is not the time to do this. Bert, really? There he comes. Microphone time. He's in position. Go at it. What are you doing up there? There he goes. Okay. Kind of keep an eye on him and look at this scope at the same time. So I've got the interesting double thing here. A slam to the side. Why is that slam to the side there? What are you doing? You can't go down there. There's nowhere for you to go. He's in investigation mode. What's that? What do you hear there? I think that's your brother. You better go check it out. Go see what he's doing. Here he comes. There he is. He's right there. He's right there. There's the bro. Don't fall. Look out. Everybody duck. What? Whoa, where'd he go? Where'd the bro go? Oh no, the bro is over here now. Oh, he's going in a secret tunnel. Oh my god, I'm overcome with cats. I'm overrun. So now, see, he's listening to his brother who's gone in behind all this stuff, but down below. He's way down below my bench. He's hearing things. No, you don't want to jump there. Come over this way. Down here. Look, I'll make a space for you. There you go. Jump down there. Come on. Come on, it doesn't get any better than that. What are you doing? Bert, you're just throwing everything off here. Meanwhile, where's your brother? He's just disappeared. Here he is. Where's your brother? There he is. Down there. One down there. One up there. Cat attack. Come on, you guys. You gotta go. Oh my gosh, don't bite that. Don't bite that. Wally. Okay. He's coming to see. What's Wally biting? I want to see it. I want to bite it too. Okay, the two of you guys are going to go for a run here because I'm going to throw something down the hall. As soon as I find something good. What would be good? A cat toy would be good. You know what really works with these guys is a bundle of wire because it's weird. It's a weird thing. There's a bundle of wire. Okay, we're going around. You ready? Is everybody ready? He's ready. Bert's ready. Bert! Come on, Wally, go. Go for it. My other cat did not take the bait. He's still there. Okay, Wally, get off that. Come on out here. You know what's happened is I've made a rearrangement of some of my my tube collection, to be specific. I'm rearranging it into a much better arrangement. It's out of my shop here, and that's cleared some space for the cat. The cat is in the space. Alrighty. Any idea what I was doing? Yes, I was looking at the scope there, at the bow tie. We were getting ready to shift it more towards the middle when the cats showed up. You shift it towards the middle by reducing the starting frequency lower. There we go. We can go a lot lower like that. So this is very, very curious now. Gotta wonder what frequency are these? Why is there only one? This is basically the output of the two transformers. This is the output of the first. This might be disturbed by the way I've connected equipment. I would think major disturbance of this would show up here too, but I noticed that this did not change much when I was hooking this up. Both my probes are on times 10. What to do next? Measure these frequencies. Why don't we try to measure or determine, not really measure, but determine what frequency this is, and this, and this. This is out of focus here. Astigmatism. Astigmatism adjustment? Maybe no. Okay. That's what we'll do. We'll get this signal generator going, stick it in the mix, see what we can find out. So this guy here is on. What I will do is I will simply hook this up to the coil too. And so both signal generators will be blasting away inside this coil and blasting away inside each other. I don't think that will be a problem. It lights the middle of the bar. That's very sensitive. So there's the antenna rod and the coil at one end. And you think you put this coil at the end where the where the antenna coil is. I get. Yeah, never mind. I disproved my point before I made it. I want this to stay up a little higher. Let's put it up. Just get it up here a little higher. There. Okay. You see, Wally has crawled out of his spot now. Wally man, go find your brother. Go find your brother. You know what? Go find your brother, and you're not welcome. Not welcome right now. Okay, we're getting to the exciting part here. Let me turn this down. Ooh, that is turned down. That's as quiet as I can get it. It is. Why did this guy go right off scale? What happened? Oh, I moved the antenna around. Let's reduce the signal here. Always better to do this with lower than signal than higher. Now, we're going to try to bring this guy in. And first we're going to watch this. I'm going to try to identify this frequency. We're going to see interference. It's going to come across and go down and come up. It's a little hard to see, but this will get quite wiggly when I get there. We think it's 200. 200, eh? Well, I can't get there from here. I can't even get there from here. I have to start here. 1 second while I calibrate things. Okay. Okay, we're at 123 kilohertz. That would be something somewhere down in this range. I'm going to boost the signal strength and see if we see it. Okay, don't see it yet. We got maximum signal strength coming out. I'm going to change this frequency up towards 200 and maybe we'll see it then. Let's go. Here we go. It's a long ways to 200. Absolutely nothing. You don't see any effect at all. Yeah, you can keep watching that screen there while I... There it is. I'm starting to see it. Okay, so it's very hard to see, but it's right in the bend here. Can I crank this up any higher? I really shouldn't. This is the most I can get. So now we're going to go up in frequency. And you see it's going down this line very slowly. Waiting for it to come up the other side. Didn't see it. Go back and try this again. They don't have to be exact. I'm just trying to prove it's around 200. Yeah, see, it's here at the neck again, or at the bend. And if I drive it down, that would be about it. It's not very distinct. So the number we're getting is 229, which matches the other measurement I made of the frequency of this peak. Well, there's no 455 showing up. There's this thing showing up, which is miles off. Now, if we try to measure these other guys here, these ones up here. Let's just see if I can move my tricky camera mount here up to the next one. There we are. How about you go in the middle? So again, what are we looking at? We're looking at what I believe is the output of the first IF. Okay, now you're seeing again some shutter effects that I don't see. That thing that's sweeping on a funny angle across it, that's just a shutter effect. Let's call it a shutter effect. What can I do here? Like, I could try tuning the transformer, but that's really difficult. I can try to make this signal show up there. The marker signal. Or did it show up? And we really didn't see it. Wow. Okay. I wish this was more distinct. So I'm going to move the signal generator frequency around. Oh, you can see it there. And I'm going to watch this very, very carefully. Just see if I see any. Like, it's jumping around as it is. Usually when I do this, it's quite distinct. So I don't see anything happening. So I'm going to go up to 455. Well, I'm not going to get there here. Okay, down to 455. Oh my gosh, there's something coming in there. That's a 680. And that's 670. Oh, there was something there. That's 515. You can hear that. This is 450 here. See a little tiny thing happening right in here. And then, well, that's interesting. If that's 450, these things are happening right close to 450. This would look like so there's the thing on the other side now. So 445. It's pretty close to 455. In fact, 455 really is right about here. Look at so the transformer appears to be resonating at the proper place, and that's probably the primary and the secondary we're seeing. They're just not on the same frequency. Meanwhile, the radio itself appears to be responding to 200 kilohertz. How do you explain that? The only way would be I'm actually on a long wave band, and that's what the radio's tuned to, 200. But then the tuning would affect that. And it does not. It does not. So we're not caught up in that fiasco. No, there's, you can't see this now at this distance, but there's a little wiggle there that's moving up and down when I do this. Goodness knows what it all means. And for the work I'm doing, it shouldn't matter what band I'm tuned to. It shouldn't make any difference in this radio. I could do it on any band, get exactly the same stuff. Really? Is that true? Is that true? I'm full of crap. Let's change bands. See what happens. Oh my gosh. Is it possible I just don't know what band I'm on? Let's go back this one. Well, this one doesn't have any nonsense. It's got nothing. There's nothing here. Well, I'm sweeping way off this. I'm nowhere near the frequency that I'm tuned to now. Okay. The thing is, my sweep is limited to 5 megahertz. I cannot go above 5 megahertz. So that means that I'm restricted to getting off the broadcast band, and I'd have to go up to either this band or all the way up to the very top. You know the thing about the top? You know when you get there. Let's go to the top. Let's go to the top band. You know what? I'm going to stop for a bit. I'll get this set up. I'm going to turn the radio off just now. I can get this set up, and then we'll look at it, because I need coffee. Yes. Just standing here trying to figure out what am I going to do next. Let's turn the radio back on. The 200 kilohertz signal, maybe that's just a wild red herring. It doesn't mean anything, maybe. It's far away from the IF. It never affect the speaker. So maybe it's something that's in this radio that was always there. And I don't know about that. Hey, how come the radio didn't... what happened here that we're not getting stuff on the scopes? What did I do? Did I stop the sweep? Hey, I just left the room and came back. Didn't do anything. I shouldn't have left the room. Where's the 200? It should be showing up here. Could be I've hooked up enough equipment now that I've just kind of quelled the whole radio. Let's move the sweep up in, and so it captures the 455. So let me just stop it. So it's only, it's only sweeping up to 133. That's really low. That's crazy low. Oh, what's that? No, that's not a stop. That's a start. It's starting at 133. Okay, we'll get it stopping at 500. What has happened? Did the antenna thing fall out? Oh, I've got it clipped in now. I changed bands. I changed bands and everything changed. So I'm pumping a pretty strong signal into the antenna. This is only 300 here, Jeff. Well, that's the middle. Middle of the sweep is 300. The sweep is running from 133 kilohertz, 500. Just below the start of the AM band. There's nothing showing up. There's nothing showing up. But I changed bands. Well, let's change bands back. What do I do with my tool? There it is. That's kind of interesting. So this is weird. As I change bands and I get between bands, so these contacts are then airborne, or the contact receivers at the back become airborne. You hear the big hum. That's not surprising. And when I get the band, the tumbler into place, it sounds like this. But when I go for the band that I think is broadcast band, I get that big hum. Just like it's not making contacts. So I'm up on some shortwave band now, don't know what. We're looking at the IF. The IF is, it doesn't matter what band you're on. I'm trying to feed in the IF an IF frequency through the antenna. But at this point, the radio is no longer anywhere like tuned. Like on the broadcast band, the radio is tuned close to the IF. But as you go up in short wave, the radio's tune is getting farther and farther, like way far away from the IF. And this is cutting down any IF type signal like I'm trying to pump into it. If it's close, a little bit of leak in, but if it's way up here, nothing's going to make it. So sweeping the way I'm doing it is not going to work on the shortwave band. We're not going to get any signal into the radio. I have to inject the signal some other way. And of course the way to do that would be as instructed. On the center, yikes, down in here. So what I would do is take this out. Just put the sweep one. One side grounded. Careful there, Jim. You got wires hanging out. One side on the chassis. It's just not the most convenient places here to clip this. And this is supposed to go down. Let's turn this way down. Down in here. So this should allow me to bypass, I believe, to bypass the front end tuning that might interfere with this. We should be able to hear this guy. Now let me check again. We're starting at 133 and we're stopping at 500. So this is going to go through the range of the IF. I don't hear anything. I don't see anything. I don't hear anything or see anything. Maybe I'm wrong about this connection. Give it more juice. More juice was required. Now, I don't see anything down here. A little tiny thing here, but what is that? What are we hooked up to here? This is on the, so this is the totalizer. This is the total output of the IF down here. And up here, oops. Yeah, that's better. Up here is the output of the first IF. Turn this down. Make this more sensitive. You can see this. Don't know what it is. This would still be around the 200 point. The 200. This is the 200 thing. But this is not. This is up around this frequency. Can we see it? Well, I got to do a little bit of adjustment on this scope. It's way out of balance here. Let's go a little more sensitive. Okay, so you can see it a little clearer now. So I'm going to try to bring in the 455 on this thing and see if we can see it. I'm going to move this a little bit to the right here so it's just a little easier to see. If I started the scan a little earlier, we would move it to the right like that too. Good, okay. Hey, a little thing there. That's okay. Now, my eyes see this much clearer than the camera does. So I'm now going to move this frequency around and see what we see here. I'm going to put this up stronger. Strongest. Okay, here we go. Show up, man. Oh, I don't have it connected. One more time on that. Not connected. How am I going to connect this? And I don't think I mentioned that. I switched the, this is on XY now, and this is the sweep coming from the sweep generator. Both scopes are using the sweep generator sweep. I didn't mention that, so in case you're wondering how I got that kind of display. Now, we want to feed this in too. Getting a little crowded in there. I'm going to take this one off. Let's click lead. So we're adding more and more, you know, free wire here. Okay, we'll put this back on. Looks the same. Ooh, scared myself. Now we want that. We want to go this on the ground. And this in here too, but not like that. Like that. Oh, that was interesting. Well, what's happening there? I don't have these leads mixed up. Oh, I don't. Well, Okay, don't know how to explain it. Wasn't really expecting that. Maybe I just have to have this on the magic frequency here that's moving around. Not doing anything. You got me as to why hooking this up would make this work stronger. No idea. Add it to the list. So we're in here. Let me turn the sweep. Maybe not what time because I can't beat the sweep here. Let me make this less potent. You can still see it up here on here. No, let's not do that. And maybe now we can see this because this guy will be relatively stronger. Let's see. And there we go. Full blast. This ought to do it. Come on, man. Where are we? 460 coming down. Oh, oh. Something went through there. The whole line got a little shaky here. How come the whole line shaky? Down at 330. I'm watching very carefully. 448 now. Probably maybe because I turned down the level or just seeing some noise. It's not showing up at all. How come? They're not showing up. Calibration check. Because when changing bands, this thing changes its output, but its calibration's good. So the whole Monty is there. What I'm trying to do is I'm trying to find where 455 really is on this line. That's what I'm trying to do. So far I got no success. Is there some reason why I can't even just turn off the radio and continue to watch the screen and look for this signal? Why can't I do that? Look, I've lined up one of these two right on the center line and the other one's halfway over, and like halfway in the next gap. So I'm going to turn off the radio. Well, that didn't help much, did it? I should have this on. Isn't it coming back? Are you coming back? You're not coming back? Is it just right off the screen? Oh, it's probably just off the screen because I've got things set. So this would be, is it Y1? Y1? I think it's Y2. There he is. Okay. Oh my gosh, that shape is still there. But the radio turned off. Does that make sense? Well, the radio turned off? Okay. I mean, it has to make sense. It's there. So let's move this thing around and see what happens on the scope there. Nothing. This just didn't work out at all. Not working out at all. How come it's not working out? How come this is not working out? What stupid thing am I doing? We don't need that on the ground, and we don't even need. What do we need? You know what I'm doing? That's stupid. I didn't hear anything. because I mean, there's a couple tubes involved, isn't there, between where I'm feeding the signal and where we're trying to pick it up? There's a couple tubes involved. They're not on. So I would say this is a dumb arrangement. The input wire, you know, I could just start doing all that stupid stuff. I hook up the signal generator directly to this coil with the radio off and try to find out what's going on that way. Done that. Let's do it again. Let's do it again. Okay, so I'm going to take the sweep signal, and I'm going to stick it right on the, what I believe is the primary of the, now what should I do with this? Should I stick it on the ground? I don't think so. But this is I'm sticking it on the ground, on the B- point. That's not really, doesn't really make sense. And then I'm going to try to stick it in here. What the heck am I doing? I have no idea. Watch the scope. Everybody watch the scope. So you can see it getting progressively wider this way, as if there's a resonance down there. Okay, I'm going to put it right on. So the idea here is somehow I'm energizing the primary side of the questionable transformer and looking at the results on the secondary side right here. So if we expand the sweep a long ways, we shouldn't have done that. What would this be? So I see something interesting here developing. This is with the radio off, feeding a sweep. What am I sweeping now? I'm sweeping a huge range. I think I'm sweeping all the way from, oh, I'm not sweeping a huge range. I'm sweeping wrong here. That's the start. That's the stop. Oh, you know what? I'm not actually engaged. This isn't right. This is better. Let's set this to, so we want to start just below 455. You know, maybe I should include 200 just to see what happens. Okay, so 150, starting at 150, stopping not way up there. Stopping at, let's say, around 500. I'm going to go up here and go down like this. Okay, just bear with me here. 500. So 550. Okay, so that's a big sweep. Let her rip. Where's it? Let her rip. Big sweep. What's a big sweep show? So this is looking at the output of the transformer. You know, I would want a nice shape here, maybe like this, because it's not being detected. So it would be shaped like that. You can kind of see that here. What's this necking thing here? Okay, so what I'm going to do, I'm going to reduce the sweep range, and that should, whoops, that should focus things. Well, that didn't work well, did it? What? I reduced it to something crazy. Starting at 150, right, we're just going through the IF. Just leave it sweeping there. Sweep and sweep, sweep it. Sweeping through the IF, and that's what we get. What is this? So if we're starting so low, okay, where are we starting? 150. And we're stopping at 550. 150, 550. What's that going to be? That's 200 again. 450's up here somewhere. I'm sure this test is bogus, though. That's the thing. Because the test equipment is throwing things off, I imagine. That's what I imagine. We're literally adding capacitance into the circuit with these leads and all this kind of stuff, especially around the transformer. Well, it's another day of nonsense in here. Made some curious observations, but they aren't, they aren't telling me what to do. I'm just making observations here. I think the biggest observation today was discovering that this tumbler, when turned to what I think is the broadcast band, which I'm absolutely going to have to settle this down, would get a very powerful hum. So what's happening here with this tumbler? These are little circuit pieces here. You pop these out, and on the back of them is a bunch of you can't see any of this. The tumbler here. These little sections will pop out. Somehow they're clipped in. They pop out, and on the back of them is a bunch of components: a coil, a capacitor, and some other stuff. So as you turn the tumbler, you're bringing up different sets of components and including them in the circuit. You can see this clearly in the schematic. It looks like when the set of components for the broadcast band are brought into place, the radio behaves terribly. And then I've spent all my time trying to troubleshoot this radio with it in the broadcast band, where something weird appears to be happening. So what would be weird? Some kind of open circuit situation in here. Open capacitor, resistor, something like that. Then you could get circuit signal conveyance transmitted and received. Like if you have a wire carrying a signal and it breaks and it's just close together, you could still transmit the signal through there, just be extremely weak. That is kind of the problem here, extremely weak. So we may be headed next into here. I think I'm not going to rush at that. What I'd rather do now is stay away from the broadcast band, do a bunch of testing with this thing set to a shortwave band, and I know for sure what shortwave band it is. Shouldn't affect this IF testing I'm doing. It shouldn't matter what band you're switched to, but we've seen there's something weird about the broadcast band, or so it appears. So I think that's the focus. Stop using the broadcast band for now. Put it on a shortwave band. Repeat some of these tests. Try to find out something going somewhere. And yeah, try to find out something going somewhere. That's my plan. Well, I know where I'm going now. I'm going outside. Another beautiful day here. And here I am in my windowless shop. Thanks a lot for watching. I very much appreciate it. I do not feel alone when I'm in here with this kind of stuff. And as much as I'm exposing my lack of knowledge and my inabilities while I'm doing this kind of thing, I still feel better about it, sharing it with people. So thanks a lot for watching. I really do appreciate it. And thanks a lot for clicking the like button. I pay attention to the like numbers and the like percentage. I find that very reinforcing also. So thank you very much for that. And that's it for today. Tomorrow we'll do what I just said. Stay away from the broadcast band. It appears to be a sick puppy. See ya.